We're here with the higher revision session from Horizon for paper 3. I'm going to start off with some crossover questions and then move into some that are the more challenging questions on the higher paper. Okay, so firstly, a nice one to start with, find the reciprocal of 9/20. So reciprocal, as we know, means to reverse the fraction if it's already in a fraction form. So this one would be simply reversing it to 20 over 9. Okay, so a nice easy start. We might possibly asked for a reciprocal of a decimal. Okay, so that one, we change it into a fraction first, so that would give us 2/10. And then finding the reciprocal of that, we'd have 10 over 2. 10 over 2 giving us 5 over 1, or just 5. Okay, so a nice easy start on that one. Second question that we've got today, we're looking at solving equations and involving angles in shapes. This one we've got a parallelogram, and one of the angle rules that I know about a parallelogram are that these two angles are equal. So that's where we're going to get our original equation from. And you'll notice that I've ignored this angle down here for now because it's got x and y in it. Okay, so that one's got two variables in there, so these are the ones that I can actually start with. So my equation is x plus 92 is equal to 3x plus 10. We've got a two-sided equation. So at this stage we need to subtract 1x from both sides. So 92 equals 2x plus 10. We now need to isolate the x's, so we're going to minus 10 from both sides. So 2x equals 82, and then divide by 2 to find out what x is. So we now know that x is 41. At that point, I'm going back to my question, find the value x and the value of y. Well, at the moment we know that x is 41, so we know that this angle up here is 41 plus 92, which gives me 133. And another angle rule that I know about parallelograms is that these two must add up to 180. So 3x plus 4y must equal 180 minus 33, which leaves me 47. And remember that we know the value of x already, so we know that 3x is 3 times 41, which gives me 123, plus 4y equals 47. So at this point we realise that y must be negative, because we're adding 123 to it and ending up with 47. Subtract 123 from both sides, and we get for the 4y equals 76. Okay, if 4y equals 76, we can find the value of y, half and half, 38 and 19. Okay, so we've got that x is 41 degrees and y is 19 degrees. Okay. Next question, we've got two triangles together and we're asked to find the value of x. We can see that x is on this triangle on the right hand side. Looking at that triangle, we've got a right angle in there. So right angle triangle, we're thinking we can use Pythagoras or trigonometry. We've got an angle in that particular triangle, so we need to just apply trigonometry to that one at the moment, although we don't know enough about it. So the triangle I'm going to start with is this one on the left. I know two sides, and the side here, the vertical side, is the one that they're sharing. So if we can work out this common side, then we can actually find x on this one here. So starting off with the triangle on the left, I'm using Pythagoras. The longest side is 20. So 20 squared equals, I'm going to call this side y up here. So 20 squared equals 16 squared plus y squared. Okay, 20 squared is 400. 16 squared, 256, sir, is that right? 16 squared, 256? Yeah. And that leaves me, if I subtract 256 from both sides, y squared equals 144. Square root both sides, we can see that y is 12. Okay, so I'm now going back to the triangle that we're trying to find with x. We can see I've now got an angle of 25 and I know a side, so I can now work out what x is. So using this triangle on the right, we're now looking at trigonometry. From the angle that I know that y is opposite the angle and x is the longest side in that triangle, so that is the hypotenuse. So using opposite and hypotenuse, that's determining that I need to use sine. So I'm going to write out the equation in full. So sine of the angle equals opposite, which is 12, over hypotenuse, which is x. Now, when we get in a situation like this where the unknown is the denominator of a fraction, we need to get that unknown to the top by multiplying both sides through by x. So we're now going to get sine 25 multiplied by x equals 12. To get x on its own, I need to divide by sine 25, so x equals 12 over sine 25. And at that point, I'm going to my calculator and make sure it's switched on. 12 divided by sine, it opens a bracket, 25 degrees, and I'm closing that bracket, pressing equals. Okay, we've got an accuracy given here. Give your answer to one decimal place, which would be 28.4. And just checking what it is that we've worked out there. We've worked out the side, and it's in centimetres, so 28.4 centimetres, one decimal place. Okay. Moving on. We've got a calculation with standard form, and this time we're asked to divide one number in standard form by another number in standard form. Well, as we're on a calculator paper, that can save us a lot of the work here. So are we okay there, sir? Is that all right? Okay, so just move the calculator across, and you can see at the bottom here I've got the times 10 to the power button in the middle of this bottom row. So if I just want to put this calculation straight in, I'm going to type it in as it shows there, so 2.31, and instead of times 10 to the minus 2, I can press the times 10 to the power button and then tell it that I want the power to be minus 2, and close that bracket, divided by, open the bracket again, 6.37 times 10 to the power, and we've got a minus 6 there, and close the bracket. Okay, so pressing answer, that should give me my answer as a fraction. I want my answer in standard form. I'm going to put it back into a decimal to begin with, and you can see it's giving me 3626 point, and I've got a recurring 6 digits here, 373626. Okay, so we need that number into standard form and correct to 3 significant figures. So in standard form, 3.6, 3 significant figures. There's my third digit. That needs to be a 3 because we've got a 6 behind it. So 3.63 times 10 to the power, and that decimal point has been moved by 3 positions. Okay, 1, 2, 3. So to 3 significant figures, we have 3.63 times 10 cubed. Okay, next question, what do we want to? Okay, so next question, we've got a cumulative frequency question. And with this question, we've also got the grid. We're given the grid to draw our graph on there as well. So Cumulative frequency. In this question then, our frequency is the number of films there, and if we want cumulative frequency, well, we better have a cumulative frequency column, which I've abbreviated there, cumulative frequency. Okay, so the number of films that were less than 80 is 0. The number of films that were less than 100 is 9, plus the 0 that we'd got from the previous group, which gives me 9. Less than 120 is 35, plus the 9, giving me 44. Add the extra 30, 74. Add the 18 gives me 92. And the extra 8. Oh, we get a nice round figure of 100. So altogether we've got 100 films. So going on to the grid. Just making sure what you can see there. Just drop that down a bit. Ooh. Struggling here, so I can't quite fit them all on. You'll have to believe me. So this time, if I just show you what I'm actually plotting here, when we're doing cumulative frequency, we're going to plot the upper value given in the group against the cumulative frequency. Okay, so those are the two values, the two columns that I need to be reading off. So my first point is going to be plotted a cumulative frequency of 0 against a time of 80. Okay, so 80 goes against a cumulative frequency of 0. If we continue with that then, if you remember, we've got 100 goes against 9, and each unit here is 2, so I'm halfway between that square there. I've got 120 against 44, there. We've got 140 against 74, 72, 4. We've got 160 against 92, which is there, and we've got 180 against 100, which takes me there. Okay, so we've plotted, we've got it on our grid. The last thing to do is to join it together, and at the moment it should be freehand. You'll obviously be using a pencil in your exam. We're doing this just so you can see it more clearly, and just join those points together. So we've drawn that cumulative frequency graph on the grid. Okay, just on the bottom of this grid now, you can see there is a follow-up question there, which says estimate the number of these films with a running time of less than 2.5 hours. So 2.5 hours we need to convert into minutes, because that's what our x-axis is showing. So we've got two lots of 60 plus 30 gives us 150 minutes. Okay, 150 minutes, and I'm showing the examiner that I know how to do these. I'm going across to 150 on the x-axis, and I'm reading up until I hit my cumulative frequency curve, and then I'm going to read horizontally across, and then I'm going to check the question again. So you can see I'm hitting around about 84 on the y-axis. But the question said estimate the number of these films with a running time of less than 2.5 hours. So my answer is 84. If it asked me for more than 2.5 hours, I would have to subtract it from the 100 and get 16. So the number of films, estimated number of films with a running time less than 2.5 hours is 84. Okay, next up, another graph. So this time we've got shade the region that satisfies all these inequalities, and we've got 3 inequalities given. We're asked to shade the region that satisfies all those. Okay, so I think the first thing to notice about these is that we've got 3 straight lines. We've got no powers on our x's here, so we're just dealing with 3 straight lines. We're probably expecting a triangle. Let's see what happens. So this first one here, x plus y is less than 4. I always think about these as being x plus y and putting it equal to 4, as if I was just drawing a straight line and figuring out points that work. Well, I like these, x plus y equals 4, so I know that x could be 4 and y could be 0, because my x and my y add together to make 4. I also know if I reverse that, I've got another point that's on that line, and also if I did 2, 2, that would make 4 as well, so those 3 points would be on that line. So if I plot those points, you can see we've got 4, 0 is there, we've got 0, 4 there, and if I plot 2, 2, you can see I've got that particular line. Okay, I'm just going to be careful here when I draw this in, because looking at the inequality, it says less than, it doesn't say equal to that line. So just to make sure, really show me, examiner, I know what I'm doing, I'm not going to draw a solid line, I'm going to put a dotted line there. Okay, in a similar way, I'm going to work out coordinates for the other two straight lines. So this one, we've got y equals x minus 1. Okay, so looking at my graph, I could maybe choose some suitable x values. Well, a nice x value might be 1, might be 2, might be 3. So if x is 1, I'm going to get y equals 1 minus 1, which gives me 0. So when x is 1, y is 0. You can plot that point, 1, 0 goes here. If x is 2, so y equals 2 minus 1, which gives me 1. So if x is 2, y equals 1. I can plot that point 2, 1. And I think we can see where my straight line's going, but just to check, if x is 3, y equals 3 minus 1, which is 2. So when x is 3, y is 2. So 3, 2 is there. You can see I've got a straight line again. And again, I'm just going to dot that line in because it says it is not equal to on the original inequality. Okay, so we've got two lines sorted at the moment. The one that I've just plotted there, just while we're looking at that one, you can see the gradient of this line is 1. So for every one we go across, we go up 1. We've got a gradient of 1 there, the missing 1 in front of the x. And we can see the y-intercept is -1, so it should go through -1 on the y-axis. Okay, moving on to my third equation then. Y equals 3x. So for this one, if x is 0, then we'll have y as 0. Y would equal 3 times 0, which gives me 0. If x is 1, y would equal 3 times 1. And if x is 2, y would equal 3 times 2. Okay, so there's my three coordinates for this one. So plotting those points, we've got 0, 0, we've got 1, 3, we've got 2, 6. And again, we're just dotting those in because the inequality is just less than and not less than or equal to. Okay, so at this point we have to now decide. So where are the y values less than 3x? Well, on that line they are equal to 3x. The y numbers are getting smaller if I go down on the y-axis. So I want below the line that I've just drawn. Okay, I also want, looking at my first one, less than 4. Well, I want them to be less than that line that I originally drew. So again, I'm below that line, I'm below this line. And looking at the middle one, we want the y values that are above. So the ones that are above this particular line. So the final thing to do is that the region that we're after is that triangle in there. Label the region R. Just to make it clear to your examiner, that region is in there. Yeah, okay, right, we'll have a quick change. Reasonably quick change. Have you got a question?
Hello guys. So I'm going to start off with a bit of algebra. Okay, so Mr. Russell went over this last time, but it didn't come up, so it's well worth going over again. Once again, it is new spec, so it could very well come up. So we've got triple brackets this time, and this will expand into what we call a cubic. Okay, key to this one, is the order that you expand your brackets in. Now you can pick any two you want to. In this case, there's not really any preference, but I would always suggest if you've got two positive brackets, start with those two. Get yourself the first working out mark really, really simply. But for this time, there's no preference. There's just a mixture of positive and negatives. So we're going to start with the first two. So 3x minus 1, x plus 5. Okay, so I'm just going to expand that just as I would as normal, and I'll forget about the 4x minus 3 just to begin with. So 3x times x is 3x squared. 3x times 5 is plus 15x. Negative 1 multiplied by x is minus 1x. I'm going to put the 1 on there just to remind myself. And minus 1 times by 5 is minus 5. And I'm just going to simplify that just to make my life a little bit easier. Those two there simplify. Please let me know if I make a mistake, Mr. Starkey. So it'll be 3x squared plus 14x minus 5. Okay, so now we've got those two brackets there have become that. So I'm going to put that back inside a bracket, and I'm going to bring down the one I have not had a chance to use that. And now I'm going to multiply everything in the big bracket by everything in the small bracket. So I'm going to start off 3x squared multiplied by 4x. So 3 times 4 is 12, be 12x cubed. That's off to a good start. 3x squared multiplied by negative 3. So 3 times negative 3 is negative 9. And just an x squared is nothing else there. 14x times 4. Remember, it is not a test of your mental arithmetic. You can do 14 times 4 on your calculator if you need to. I will double check. And it is 56. So 14 times 4 is plus 56. And remember, it's x times x. So that is x squared. And 14 times negative 3. Once again, don't be a hero. 14 times negative 3 is negative 42. And remember, that's an x multiplied by not an x. So we've got an x there. Nearly there. Negative 5 now multiplied by 4 will be negative 20x. And negative 5 multiplied by negative 3 is positive 15. Once again, if you don't like your negative numbers, I know a lot of people don't, double check it, put it in. Negative 5 multiplied by negative 3 is positive 15, okay? Now, we need to get somehow from here to there. So let's see what we've got. Well, we've just got a 12x cubed there. That's the only x cubed we've got. So we've got 12x cubed. That bit's done. We have now got 56x squared, subtract 9x squared. So if we do 56, take away 9, once again, double check. There we go, 47x squared. That's looking good so far. Then we've got negative 42, subtract 20. Well, now we should know that should make negative 62, but double check. We're at negative 42, we're going down 20. Yeah, that is negative 62x, and we got that plus 15 on the end. So we are all good. You know you've got that right. Those marks are in the bag. Remember, for a show that question, do not use this answer to help you. That is just your end product. Okay, so do all your working out and then just double check that your answer matches that, and this time it does. Okay, sticking with the algebra theme then. And the lights are gone out. 1 second while we just turn those back on. Everyone's left us, I think. We are back. So, by completing the square, find the coordinates of the turning point of the curve of the equation y equals x squared plus 8x plus 3. You must show all your working, okay? It's quite nice this time. It tells you what to do. It's not necessarily going to do that. So if it says anything about turning points or minimum or maximum points, anything like that, you will have to complete the square. So if I just write the question out again so we can probably see it a bit better. X squared plus 8x plus 3. So to complete the squared, I'm going to put some brackets in. I'm going to put an x in. I'm going to put the square there. Then whatever my number in front of my x is, I'm going to half it. So we've got x plus 4 squared. Now, a lot of you have got to the point now where you can do this next bit in your head. I'm just going to do it the long way just to make sure those of us who aren't quite certain can see what's happening. So I'm just in the corner over here. I'm going to work out what x plus 4 squared is. Okay, remember, when it says squared, it means the whole thing multiplied by itself, not just x squared plus 16. So we've got x times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. So that would become x squared plus 8x plus 16. Well, you can see we've got that by expanding what we've got, but in a question, we want positive 3. So how do we go from this 16 to that positive 3, we are going to subtract 13. So there we go. That is that equation in complete the square form. Okay, it's exactly the same, but it's just written differently. So to find the turning point then, the turning point will be a coordinate. And what we do for that is we take the negative or the opposite of whatever's inside this bracket. So instead of plus 4, we're going to have negative 4. That is going to be your x value. And then your y value is going to be whatever's on the outside, however it is. So that's negative 13. And that is what your turning point is for that. Okay. Next then, we are continuing with this sort of theme. And we've got a quadratic sequence. Another thing that we... a topic we covered before last exam. Once again, it very easily could come up. So whenever I do any sort of sequence, first thing I'm going to do is find a difference. You okay, sir? Yeah. So from 2 to 14, I am going to add 12. From 14 to 36, just double check. Take away 14. It's been a long 2 weeks. So add in 22 there. And from 36 to 68, we're going to add 32. Okay, so I'm just going to do it down here where I've got a bit more space. Okay, so we've got 12, 22, and 32. I'm then going to find the second difference. So just the difference between those numbers, and each of those is 10. Now, whatever answer you get for this, we're going to half it. So therefore, it will be 5n squared. Apologies for those of you who like to do it Mr. Russell's method. I'm not going to do it that way just for now. If you'd like to go over that again, I'm sure he'll be more than happy to in the morning. Okay, so over here now, I'm going to write my sequence out again. So that's a 2, believe it or not. 14, 36, 68. And underneath that, I'm going to put the sequence for 5n squared. So remember, that is the square numbers just multiplied by 5. So there's nothing wrong. Write down the first 4 square numbers. 1, 4, 9, 16, because 1 times 1, 2 times 2, 3 times 3, 4 times 4, and then we're going to multiply those by 5. So that would be 1 times 5 is 5, 4 times 5 is 20, 9 times 5 is 45, and 16 times 5 is 80. Now then, so this was my sequence. This is 5n squared. I need to see how do I get from 5n squared to my sequence. So to get from 5 to 2, I'm going to subtract 3, so I'm going that way. From 20 to 14, I'm going to subtract 6, and from 45 to 36, I'm going to subtract 9, and from 80 to 68, I'm going to subtract 12. So the last part of my sequence then is whatever that sequence is. Now we can go in, it's going from minus 3, it's going down in 3s, so it's going to be minus 3n, and because that's already minus 3 is already minus 3, we don't need to do anything to that, so that's all it is. So this sequence is 5n squared subtract 3n. So to answer the question then, in the term pn squared plus qn, find the value of p and the value of q. Well, p is pn squared, so my p is 5, and it says plus q, that's absolutely fine. Our q is just going to be negative 3. That is not an issue. Sticking with the sequences. You got some more there, sir?
No. Somebody just asked what we've done so far.
Okay. So here we go. What everybody's favourite, use the quadratic formula to solve 5x squared plus 11x subtract 2 equals 0. Give your solutions to 2 decimal places. I know a lot of people have had this memorised. If you haven't, maybe spend some time doing that. I'm going to put myself on the spot here. So, the quadratic formula, please check me if I'm wrong, sir. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a.
Perfect.
Brilliant. Okay, so I'm just going to label here, just so I can show the examiner exactly what I'm doing. I'm going to write down what my A, B, and my C is. Now, I know some people like to write it on like that, which is absolutely brilliant. You know what you're talking about, but just show them that even more. So A equals 5, B equals 11, C equals negative 2. Now, it does matter that that's negative. We're now just going to substitute straight into the formula. So if I've got minus, we said B is 11, so it'd be minus 11, plus or minus the square root of b squared. So I've got 11 squared. Now, I would always suggest you put that in a bracket. Just in case it's negative, your calculator won't get it wrong then. Subtract 4 times 5 times negative 2, sorry, make sure that goes all the way up, all over 2 times 5. Now, calculators are absolutely brilliant. You can put that straight into your calculator. Now, remember, there's probably going to be two answers for this because we've got a plus and a minus. Okay, so I'm going to start off with the plus. I'm going to type that into my calculator exactly that it is, apart from instead of plus or minus there, I'm just going to have a plus. So, we got put as a fraction, negative 11 plus the square root of 11 squared minus 4 times 5 times negative 2 all over 2 times 5 equals, and it's given me an answer. That's good news. Press it as a decimal, and it says your answer to 2 decimal places. So I'm still going to write it out in full first, just to show that I've done it right. 168857754 to 2 decimal places. That would be 0.17. Remember, there is going to be a second answer as well, so that's what happens when we do it with a plus. I'm now going to press my left button to go all the way back, and I'm going to just swap that plus for a minus. I'm not going to write it all out again because that's a waste of time. And my other answer then will be negative 2.3688577754, or to 2 decimal places, negative 2.37. And they are my 2 solutions for that. Okay, remember those 2 solutions are where the graph crosses the x-axis. Personal favourite, easy marks that people always seem to panic on. There are 14 boys and 12 girls in a class. Work out the total number of ways that 1 boy and 1 girl can be chosen from the class. Thank you. So, to use this, I need to think, well, how many ways are there of choosing a boy? Well, there's 14 ways. How many ways are there of choosing a girl? There's 12 of those. I'm just going to multiply those together. That's simple. 14 times 12 is 168. Done. Next. Here we go. A personal favourite. New spec. Still not come up. We're waiting for it. It's about that capture, recapture. So Beth this time, for some reason, she wants to estimate the number of frogs in a lake. She catches a sample of 80 frogs. She marks them, I don't want to know how, and she puts them back in that lake. Later that day, in a second sample of 80 frogs, she finds 10 of them are marked. Okay, so work out an estimate for the number of frogs in the lake. So we're going to do this like equivalent fractions. So on the first day, she caught 80 frogs. Must have been a busy day, and we don't know how many there were overall. I'm just going to put a question mark. You can put a letter, you can do whatever you want there. Then, later on in the day, she picked out 80, so the total was 80, and she found that 10 of those were marked. Okay? Now, in order to do this, we're just going to assume that those are equivalent fractions. We've assumed that the population hasn't changed. So we used to work out what that missing thing is. So to get from 10 to 80, we multiply by 8. So we're just going to multiply the bottom by 8. 8 times 8 is 64. 8 times 80 is 640. Remember, use your calculator if you want to. It is not a crime. Now, part B then, easy mark, because these are the same every single time. Write down any assumptions you have made. Well, there's 2 possible ones. Firstly, that the population, I've already mentioned it, doesn't change. Okay, that's all you need to say. So the population doesn't change. There are the same amount before and after. And number 2 is that it has to be a truly random selection. If not, she could just be picking the same frogs out twice. Okay? And that's it for that one. Oh, we're getting into good ones now, sir. Prove algebraically that 0.73 recurring, I'm not sure you can see this, equals 0.63 recurring. Okay, now, if it comes up on a calculator paper, it's going to be something similar to this, where it says prove algebraically. You cannot just put that in your calculator and say, oh, it tells me it is. Okay, we need to solve that. So we're going to do it a little bit at a time. So to start off, I'm going to do x equals 0.73333, and so on and so on, as many as you want. I'm then going to multiply this. so that I've got left with just the recurring bit on its own. So in this case, I'm going to multiply by 10. So that will give me 10x equals 7.3333. I'm now going to multiply it again so that I get one bit of the recurring bit over the other side. So I'm going to multiply it by another 10, which means overall I've got 100x equals 73.333. Well, now I've got two values now where the recurring part, or the decimal part, is exactly the same. I can just do one, take away the other. So 100x take away 10x is 90x. 73.333, well, they cancel out. Then I'm just left with 73, take away 7. Once again, if you're not sure, double check. Okay, I don't want any silly mistakes tomorrow, guys. 66. So x then would equal 66 over 90. Now you can simplify that if you want to, or you can just leave it like that. I'm now going to do the same for the other side. Now, if you want to use x again, you can do. I'm just going to be a bit more mathematically correct. I'll use a different letter. I'm going to call this one y. No real reason. 0.6363363. Remember, the dot above the recurring decimal, the first dot is where it starts, the second dot is where it ends. So, once again, I'm going to multiply it by something so that I get all of that recurring bit over the other side. So we're going to go straight into 100x this time. So 100x equals 63.6363. We're on y. It's been a long day. Okay, well now I can see, well, I've already got the same of my decimals here. So I'm just going to take one straight away the other. So 100 take away y is 99y. 63 take away, well, that disappears, we're just left with 63. So y would equal 63 over 99. So last bit then, I'm multiplying those together. So I've got 66 over 90 multiplied by 63 over 99. Now, remember, multiplying fractions is good to know. Top times the top, bottom times the bottom. Or you can use your calculator, put them in. 66 over 90 multiplied by, moment of truth, 63 over 99. That equals 7 over 15. If you really want to show off, you can do each bit individually. You can do 66 times 63, which is 4,158 over 90 times 99. Sorry for not doing that one in my head, guys. 8,910. And then you can use your calculator to simplify it. We'll go down to that. Okay, so we know we've got it right because that is what we were looking for. How many more have we got? These are the same one, I think, so I'll finish these off.
Okay.
Okay.
We've got the quadratic simultaneous equation to finish.
Is that your turn? I got it wrong last time. Okay, so show that the equation x squared plus 4x equals 1 has a solution between x equals 0 and x equals 1. This seems familiar. I may have covered this one last time. Apologies if you've already seen it once. It doesn't hurt to see it more than once. So, to show that the equation has a solution between x equals 0 and x equals 1, we are going to substitute both of those into that equation there and see what they come up with. So, this is what I'm looking at, x cubed plus 4x. Firstly, I'm going to substitute in x equals 0. So I'm going to have 0 cubed plus 4 lots of 0, which is 0 plus 0, and that equals 0. Okay, I'm now going to do it where x equals 1. So I've got 1 cubed plus 4 lots of 1. So 1 cubed is 1, 4 lots of 1 is 4, and that equals 5. So for the first one, we had x equals 0. For the second one, we had it equals 5. Sorry, for the value was 0, and the second one, the value was 5. Well, we wanted 1, so because 1 is lower and 1 is higher, it must be in between. Now, this is the first two parts of an iteration question where actually the iteration isn't even done till the last bit. So if you don't like iteration, that's absolutely fine. You can still do part A and B. So part B, show that the equation x cubed plus 4x equals 1 can be rearranged to give this. Okay, so there's more than one way of rearranging these equations. So I'm going to look at this and it's going to give me a clue. Now, I can see I've still got my x cubed there. That's not gone anywhere. Okay, so I've not cube rooted at all. So I'm going to try and get the other x on its own. So I'm going to try and get that 4x on its own. So if I've got x cubed plus 4x equals 1. To get that on its own, I'm going to take away x cubed from both sides. So that disappears. I'm left with 4x equals 1 subtract x cubed. Now then, I want to get x on its own, so I'm going to divide both sides by 4. So I've got x equals 1 minus x cubed over 4. Now, last time I remember looking at this thinking that's not the same. Actually, it is, because with the way that adding and subtracting fractions works, as long as the denominator is the same, we can split those two up. So that actually is the same as 1 over 4 subtract x cubed over 4. Okay? Part C then. Even if you can't do that bit, it still gives you enough information you need for part C. So starting with x0 equals 0, use the iteration formula. So it tells you that's the formula you need to use. We're going to do it twice and find an estimate for the solution to that. Now, don't worry yourself too much about that. We're not actually going to use that at all. This is just a way of solving cubics at GCSE. You go into that in more detail at A-level if you carry it on, but we're going to just find an estimate for now. So I'm always going to write down the first one it gives me. So it tells me that x0 equals 1. And every single time the way it's going to work is the answer you get is going to become x1. So I've got 1 over 4 subtract. Now I've got my x there. I'm going to substitute my last answer in for x. So 0 cubed over 4. Okay? Now I'm just going to type that straight into my calculator. So I've got my fraction 1 over 4 subtract, and I'm going to put this another fraction, and I'm just going to put it in brackets just in case I've got any negatives. 0 cubed over 4, and that will give me 1 quarter. Okay, well it says I need to do it twice. I've done it once, so x2 then will be my second time. I've got 1 over 4 yet again. Take away. Now remember last time my x was 0. Now it's going to be 1 quarter cubed over 4. Now to do that, my calculator is really, really handy. All I'm going to do is go back to where I put 0 there, delete that, and press that ANS button. And that uses your last answer, so you don't even have to remember what it was. Press equals, and that will tell you that that is 663 over 256. For those of you that prefer decimals, it is 0.2460937. Well, it says do it twice. I've done it twice. Now it says give you answer to 3 significant figures. So we do need is a decimal there. We need to round that. So 3 significant figures. The first 0 doesn't count. All the later ones do. So we're going to count 1, 2, 3. They're my first 3 significant figures. It's a 0, so we're not rounding up. So our answer would be 0.246. And there we are. We are done. If the question just doesn't tell you how many times to do it, and it says just find an approximate solution, just keep pressing equals and then write down each one as you go. x3 equals 0.24 blah blah blah, then x4 equals, and carry on until you've got 1 or 2 decimal places, whatever it says, that stay the same each time, and you're set. Okay, there we go. Sasaki, are you taking over or?
Yeah. Quick change. So we've got 3 questions left. We've got reading roots from a function of x on a graph. We've got a division of an algebraic fraction, and then we've got solving quadratic simultaneous equations algebraically. Okay, so this first one then, we're given the graph. Sorry about the font on this, it's not too clear. We've got the graph of y equals f of x, function of x is drawn on the grid. Part A, write down the coordinates of the turning point of the graph. So a nice easy one marker there to begin with, if we can read it. So my turning point's there. So when x is, sorry, I'll just change my pen. So we've got 1, 4 there. So 1, 4, nice easy start. Part B, again, just a one marker, write down the roots of the function. Well, where it equals 0, well, that function equals 0 here and here. So the roots are when x is -1 and when x is 3. X equals -1 or x equals 3. And then the final part of that question, we've got write down the value of f, and then we've got 0.5. Now you can see the 0.5 has taken the place of the x. So that's what we're going to read from. So we'll find x at 0.5 on our x-axis, and we're going to read up to our function. And we're just going to read off then horizontally to see what we get. And hopefully it'll be much easier to read. And I've got 1, 2, 3, 4, 5, 6, 7. So 3.7 is the value of the function. Okay, 3.7. Okay, so reasonably quick, those questions. Right, a couple of slightly nastier questions to move on to. This one says question 2. I'd be surprised if it is question 2 on our paper tomorrow. So we've got two quite nasty fractions here. Remember that even though they've got some plenty of algebra going on in there, they are still fractions. So if we're dividing fractions, we need to be thinking about how we do that. So remember that we're going to change the operation from a divide to a times, and because of that, we're going to invert the second fraction. That will then give us the correct answer. So we're leaving that first fraction as it is, 6x squared plus 7x minus 5. And we're changing the divide to a times, and we are inverting the second fraction, 4x squared minus 1 over 1. We've found the reciprocal. We're back to where we started off today. Okay. Now, looking at these two expressions, we've got a quadratic expression here on my first fraction. I've got a quadratic expression here on the second fraction, and this second one is the one that's drawing my attention because I'm recognising that as a difference of two squareds. So we've got a squared term, we've got a square number, and we've got a difference, we've got a subtract in between them. So that's where I'm going to start. So that 4x squared minus 1 can be factorised into 2x plus 1 and 2x minus 1. So remember, you actually square root each term, and to make the minus 1 at the end, it must be positive 1 times a negative 1. So that's all over 1. And that's giving me a bit of a clue over here, in that when I factorise the expression on the left, 6x squared plus 7x minus 5, I'm pretty sure that one of these factors is going to be repeated over here. Well, as they both start with 2x, that's a big help. So again, I'm going to write down two brackets. And if I know that one of these is 2x, because both these are, this one must be a 3x to make up the 6x squared over here. I'm now looking at this negative 5 that I've got at the end, so I know that it must be a 5 and a 1 in the ends, the two end terms in the brackets. And maybe you might have to do a bit of trial and error here, but actually if I put a 5 there and the 1 in that one, I need to make a positive 7x. Well, if I make the 5 positive, that's going to give me 10x here, and then if I've got a negative there, that's going to give me minus 3x. So I can see if I multiply that out, 2x squared times 3x is going to give me the 6x squared. 2x times 5 is going to give me 10x. Minus 1 times 3x is going to give me minus 3x there. Those two combined will give me the 7x. And then I've got the minus 1 times the 5 giving me the minus 5 in the end. So I'm happy that I've multiplied that. I've factorised that correctly. Okay, multiplying fractions. We multiply the two numerators together, so that's going to stay as 2x plus 1, 2x minus 1. And on the denominator, this is going to stay as 2x minus 1, 3x plus 5. And all I look for now is where I've got complete factors that match. So I can cancel top and bottom by 2x minus 1. And we're just left with 2x plus 1 over 3x plus 5. So a quick check at our question. Show that this fraction divided by this fraction simplifies to ax plus b over cx plus d, and you can see that this matches the format that we've got here. A, B, C, D are integers. It doesn't ask me to state what A, B and C, D are, but I'm just checking that I didn't have to do that. Okay, so that's that one completed. Okay, moving on. We've got a Simultaneous equations. What's that? Okay, that'll be yours to finish, sir. That'll be a special treat. But we'll be into overtime. Okay, so we've now got simultaneous equations to have a go at. Simultaneous equations with a quadratic. Now, this did come up graphically on paper 2. If it crops up algebraically, then it may look something like this. So this requires substitution, and I'm going to start, I'm looking at this top equation now. I'm going to make y the subject from that top equation. So if I subtract 2x from both sides, this top equation will become y equals 11 minus 2x. Now looking at my second equation, you can see that one of the terms is y squared. So if I square y, remember to write this bracket twice, I can now get an expression for y squared. So I'm going to multiply out those two brackets. So y squared equals, well, 11 times 11 is 121. We've then got 11 times minus 2x, which is minus 22x. I'm going to get a repeat of that. Minus 2x times 11 is minus 22x. And then I've got minus 2x multiplied by minus 2x, which is plus 4x squared. Okay, so a bit of tidying up there. I've got y squared equals, I'm going to bring the 4x squared to the front. Minus 22x minus another 22x is minus 44x. And then I've got a positive 121 there. So what we've got now is an expression for y squared. And that expression can be substituted into that second equation. So my second equation is now going to become 2x squared. And we are subtracting y squared. And I'm going to put all that into a bracket. So I've got 4x squared minus 44x plus 121. And all that equals 23. Just room there to fit that 23. Okay, so let's remove those brackets and we'll see what we can do. So 2x squared minus 4x squared is going to give me a negative 2x squared. And this negative is going to act on all these terms in the bracket as well. So I've now got, I'm taking away a negative here, so I'm adding it, so that's going to become plus 44x, and then I'm subtracting the positive, which is going to be negative, so that's minus 21, and I've got equals 23 on the right-hand side. So at the moment, looking at that, I can see I've got a quadratic equation. If I've got a quadratic equation, I need to make that equation equal 0. So I've got a bit of rearranging to do. I'm going to move that negative 2x squared over on the right-hand side and make it positive. So I'm going to have 2x squared on the right-hand side. If I subtract the 44x, that will become negative. At this side, I want to have 0 on this side, so I then need to add the 121 onto this 23 that I've already got there, which gives me 144, and that will be positive. Okay, so I've now got my quadratic equation equaling 0. At this point, I'll have a quick look at it and realise and sort of celebrate that all my terms can be divisible by 2. So we've now got 0 equals x squared minus 22x plus 72. And it may take you a bit of time here to try your factorising on this one, to try and solve this equation. And yeah, we can make factors that work this time with 18 and 4. So 0 equals 2 brackets x. This positive sign at the end is telling me that my signs must both be the same, and in this case they're both negative. And 4 times 18, or negative 4 times negative 18, gives me positive 72 at the end. Minus 18x minus the further 4x gives me a negative 22x there, and we've got x squared at the beginning. So we factorise that correctly. Solving from there then, we know that x equals 4 or x equals 18. So our last step on this one, remember that if you're solving these equations, we've got to find the value of y as well. So we need to pop these values back into that. I would choose the top equation, which is much nicer than the bottom one. I'm going to substitute back into there. So I've got, if x is 4, then I'm going to get 8 plus y equals 11. So y will equal 3. So 1 point, if I'm asked for the coordinates where these two equations intersect, then x is 4 and y is 3. And the second one, if x is 18, we've got 36 plus y equals 11. So y would equal minus 25. So my intersection this time will be 18 and minus 25. Okay. Quadratic simultaneous equations algebraically. Right, sir. Are you?
One more.
What, you onto that one?
Yeah.
Yep.
One more to leave you on.
Brilliant.
Okay, guys. So, excuse my hastily drawn question here, but I just noticed I haven't done one like this in a while. Okay, so once again, check my formulas. A bit rusty. Okay, so here I've got a triangle, and I want to find x. I'm looking for that. So my thought process immediately is, and we've got a triangle here. Is it a right angle triangle? Well, no, it's not. It tells us the angles. That's definitely not 90 degrees, so it's not right angled. We can't use SOHCAHTOA. We can't use Pythagoras. Okay. And then I need to see, well, do I know an opposite side and an opposite angle? And yes, I do. Okay, I know that one there and that one there. So I can in fact use the sine rule. Okay, so we've got, I'm trying to find a sine rule for a missing side. So my sine rule says A over sine A equals B over sine B equals C over sine C. So remember, we need to label each of these ones. So the points are the capital letters, that they are the ones on the bottom here with the sign, and their opposite angles are the little letters, so A, B, and C. Now, I can see here I'm trying to work out what A is, so I need that part. I know what B is, so I need that part. Oh, sound a bit different here, doesn't it? What's going on here, sir? Nope. Sorry, just confused myself. We don't know anything about C, so we're going to ignore that one. Okay, so I don't know the angle for C, I don't know the side length C, so I'm going to ignore that. So I'm just going to substitute in each bit I know there. So I've got x over sine 33 equals 15 over sine 112. Is that okay, sir?
Yeah, you can get angle C because it's.
I could work out angle C, yeah, but at this point I don't need it. Okay, I was panicking for a second, I was getting confused with my C's. Okay, so to work out my x, I would do 15 over sine 112 multiplied by sine 33, and that will tell us what it is straight off the bat. So 15 over sine 112, close your brackets, multiplied by sine 33, close your brackets, is 8.8 centimetres to 1 decimal place. One last thing to leave you on, it's not come up just yet, so please make sure you have learnt your formulas. We went through the quadratic one. Also, please remember this one: a squared equals b squared plus c squared minus 2bc cos a. Anything else, sir?
Just had a quick request for cosine rule, but actually it's area of a triangle, but it's saying.
Okay, so just while Mr. Starkey writes down this question, then we'll give you one last one to leave you on. So we're talking about the area of a triangle used in trigonometry. Okay, so to do that, we are going to use half AB sine C. Now, so that's just for the area. Okay, so if we've been given this crudely drawn question here, so can we see both of those on the screen, sir?
Hang on, let's have a look. Yeah, lovely.
Brilliant. So this is my formula where A and B are small, so they're talking about sides, and C is big. Now, the only thing that matters for this is that the angle that you've got is C. So that would be C, that would be little c. A and B, they don't really matter. They're just the sides either side. So to find the area for this, all we do is substitute straight in. So we're going to do 1/2 times A, which is 6, times by 7, which is B, times by sine C, which is that 60, sir?
Yeah, sorry.
Okay. Calculator does all the work for you here. You don't have to remember your exact trig values for this. So 1/2 or 0.5, whatever you prefer, times 6 times 7 times sine 60. That is a horrible third, so we'll put it as a decimal. It's 18.2 centimeters squared to one decimal place. Remember, that is working out the area. Whenever we got area, centimeters squared, that could be a whole mark there. Even if you don't know anything else, put your units. Is that it, sir?
That's about it, unless you want to do a cosine related to that one.
If you've got one.
Do you want a different question, or do you want to find angle A from that one that you're on?
Okay, so we'll go to pink this time then. You could also be here asked to find angle A. What way do you use? Do you remember the second formula, or do you rearrange it?
I rearranged it. Yeah, I remember one version of the formula.
Okay, so
It's me 8, sir.
we've got a squared equals b squared plus c squared minus 2bc cos a. So this is the last one for me, guys. So I'm going to substitute in everything I know. So I know a squared is 6 squared equals 7 squared plus... You sure I want to find angle A, sir? Means side C.
What we got missing? We may need the sine rule first. Find the area. What you got missing? 2 things.
Yeah.
Yeah. I need a bit more. We got 2 sides.
Oh, you've dumped me in this, so do you want to come get yourself out of it?
No, I don't think you're right. I don't think we can do it.
Find angle A.
What we worked out area.
Mr. Stark is thinking, guys, apologies. He's trying to get himself out of this.
Yeah, yeah. Yeah, you'd have to do a 2-stage when you'd have to find side C first, I think. But we don't know A though, do we?
No, we don't.
You'd have to relabel it, calling, you'd have to relabel your triangle and call C A,
Right.
so that then you can use that angle.
So it's 2 steps.
So it's 2 steps.
Do you want to do it?
Go on then.
Go on. Starky's going to...
Let's have a go. So we're gonna have to relabel, aren't we? Just we're going well. Yeah.
Too well.
We should have switched off at 8. We were all right until then. Okay, where have we got to? So we've got some more papers. I've got a bit here. So if we've got, going back to my original triangle, we've got 2 sides and an included angle. So I'm just going to redraw that triangle again. So we've got 7 centimetres here. We've got 6 centimetres here. We've got an angle of 60 degrees there, and we're asked to find angle A. Okay, so if we were sticking with the same, this is what's thrown us. It's because we call that angle A, opposite side A, but we need to refer to this one as being A. So as long as we find the correct one, it wouldn't be A anymore. So we'd have to relabel it if we want to stick with that same one version of our cosine rule. Okay, so I'm going to label the one that I know. I'm going to change that to A. So this is B, and actually the one that we're finding is angle C. So let's get rid of that. So that becomes little c, and that becomes little b in my formula. Okay, so are we all right now, sir? Do we think we can do this? Okay, so substituting in everything that we think that we know then. So we've got little a over here, which we don't know, and looking at my formula now, we know b, so we know b squared, we know c, so we know c squared, we've got b and c again, and we've got cos a, and we now know cos a. So we should be okay to find that side. Okay, so a squared equals b squared is going to give us 36 plus c squared, which is, sorry, I've got those wrong way around, but you'll realise that it don't matter because we're going to add them together anyway. So we've got 49 plus 36 minus 2 times 7 times the 6 multiplied by cos 60 degrees. Okay, so if we put that into our calculator, let's cover that bit up. Let's just get back to that bit. Are we all right there? So can we see that? Okay, so at this stage then, I try to delay going to my calculator for as long as I can. So those two there can be added together to give me 85. And then over here, I've got 42 times 2, which is 81, and that's 81 cos 60. Okay, so at this point then, I'm going to type that in. So I've got 85 minus 81 times cos, it opens a bracket, 60, close my bracket. Okay, so that gives me 89 over 2. I need to square root that because I've got a squared. So square rooting that, square root answer equals. And I'm going to take that to 4 significant figures because I'm going to have to use that value again. So we've got 6.671 as side A. 6.671. Okay, so we're now trying to get to the angle that we're after. We've used the cosine rule there. Well, we're now after this angle C, and at this point I think we'd then use the sine rule because we've got a matching angle inside here and a matching angle inside here. Okay, so the second part of this question, if we're finding an angle, well, using the labelling that I've got now, I know that sine C over C is equal to, the other ones that I know are sine A over A. Okay, so sine C is the one that we don't know. C we know is 6. Sine A is 60 over A, which we've just worked out as 6.671. Okay, so multiplying both sides by 6 will give me sine C equals sine 60 over 6.671 multiplied by 6. And if we want to work out C, we need to get rid of the sine, we need to do inverse sine, and then we want of all that lot. So we've got sine 60 over 6.671 multiplied by 6. So going to my calculator, we should be okay to do that. So we've got shift inverse sine, it opens a bracket, we've got sine 60, close your bracket, divided by 6.671, and I want then to multiply by 6 and close the bracket again at the end. Have I closed enough brackets there? So I think okay, and we get our angle C, 3 significant figures, is 51.2 degrees. So there we go. So sorry about a bit of confusion there. Trying to write questions and answer them on the hoof is probably not to be recommended. Georgia Healy, thank you very much for that one. Right, that's all from us. We need to get home, ready for boosters tomorrow, starting at 8:15. Mr. Sanders needs his beauty sleep, so thanks for listening. Hope that's been helpful.